say this is omega 1, this is omega 2, this is A1, this is A2. So this is for two pole system. This equation is for two pole system. It will be helpful in calculation. Two pole system. This is for two pole system. Omega square is inversely proportional to gain. Okay, so when there is a roll of minus 40 dB per decade for that much of that region only. So this is minus 20, this is minus 40, this is minus 40 dB per decade. Say we have only two pole system, so like this is minus 20 dB per decade. Okay. So for this region, for this equation is for this region, and this equation is for this region, for single pole system. So just remember, note down these equations though, because this will be helpful in calculation purpose. It will be good if you know this equation. So now suppose you have two pole system and 1 0. Okay, one say left and 0, or we will see only magnitude plot. So say you have this first pole, and here second pole is coming. Okay, and this one. Now suppose this is P1, this is P2. Okay, now suppose you this is two pole system. Now suppose you are having a 1 0. Say 0 will come somewhere, say here. You put in your circuit, when you design, you put 0 here. So we know 0 will give you plus 20 dB per decade. So this is minus 20 dB per decade because of pole, and 0 give you plus 20 dB. So if you are inserting your 0 here, okay, so this will give plus 20 dB per decade. Okay, so this will give you 20 dB per decade. Now this is minus 20 dB per decade, this is plus 20 dB per decade. So in this case you should get your Bode plot modified to 0 dB, because this is minus 20 dB per decade roll off, this is plus 20 dB per decade. So it should be 0 dB when you add both, and at this point it will again be minus when your second pole comes. This is P2 and minus 20 dB per decade. So here, so new plot will be like this, and like this. Okay, so this is your two pole system. This is two pole system with 0, 2 poles plus 1 0. This is for two pole. Okay, I hope you understand these Bode plot concepts, how pole and 0 is going to impact your Bode plot. And suppose, okay, one more example we will take. Till now we are inserting, we are taking two poles. So say this is your pole 1, so it will roll off by 20 dB. Then you take second pole, it will again minus 40 dB. So this is say P1, this is say P2. Okay, so this is your two pole system. Okay, now this is minus 20 dB per decade, this is minus 40 dB per decade, because you are adding another pole in your minus 20 dB. So if this pole is not there, it will goes like minus 20 dB like this, but you are adding another pole, so it will again gives you minus 20 dB roll off, so it will be minus 40 dB. Now suppose you are putting 0 say at this point. Okay, okay, I will add here, this is your 0 z1. Now you are putting here 0 z1. Now what it will do, it will give you positive, again positive 20 dB, so it will move this to like this. Okay, so this is my again minus 20 dB per decade. How? You have a roll of minus 40 dB. This is minus 40 dB due to P2. You are putting somewhere here Z1, which is having a roll off of plus 20 dB, plus 20 dB. So if you add these two roll off, it will come like minus, this is minus 40 plus 20 minus 20 dB per decade roll off. Okay, so I hope now you understand how this pole and zero affects your Bode plot. Let's take one more example, and in this example we will put 0 on P2. So let's draw. So this is your first pole, this is second pole, so this is P1, this is P2. Okay, okay, so before going further, we will see actual plot. So actual plot for this is something like this, and this go. Okay, so here minus 40 dB per decade roll off, here minus 20 dB per decade, here minus 20 dB per decade. Okay, now let's see this one. Now let's see this one. Now in this case, suppose this is okay, so this is minus 20 dB per decade, this is minus 40 dB per decade. So this is magnitude in dB, this is omega. Now suppose we put 0 at P2. So what will happen? So this 0 gives minus plus 20 dB per decade. This pole 0 also minus 20 dB, and total slope minus 40 dB per decade. So this 0 is going to cancel effect of this pole, and when it cancel effect of this pole, you will get what you will get? You will get minus 20 dB per decade. So it will shift here. So actual minus 20 dB per decade. Okay, so actual plot will be something say like this, and after putting 0, I mean this. So from here to till here, or after this P1, this is actually straight line. This is actually straight line. My line is not very much straight. So yeah, so this full is minus 20 dB per decade. So in this case, at this point, this system act like a single pole system, because roll off is minus 20 dB per decade. Here also at this point it is minus 20 dB per decade roll off near UGB. So this is a single pole system. So this point is UGB. Okay, so here also at UGB it is minus 20 dB per decade roll off. So this act like a single pole system. Here also at omega UGB roll off is minus 20 dB per decade. So system act like a single pole system and stable. So we try to make our system as a single pole system. Roll off near UGB should be minus 20 dB per decade, so that our system is stable and we are having a good enough phase margin. Thank you.